let's now look at operations on number basis, operations on non-decimal number basis, right? So let's start with addition. Right, so we are to add, right? So the first thing to do is to make sure you arrange the numbers, vertically in the appropriate order, right? Just as you were doing back in primary school, right? So if you are asked to add some numbers, so assuming here we have to solve 1 2 3 base 4 plus 12 1 2 base 4. So assuming it was in base 10, how would you have arranged them vertically, right? So that is the same thing we are going to do under non-decimal number basis. Alright, so that is it. Another thing to note when adding numbers in non-decimal basis is that if the total is less than that given base, you maintain the same number. Right? Good. And then if the total is equal to that given base, you would interpret it as 10 in that new base. I believe you get me. So it means that 5 in base 5 is what? Is 10. This is the reason. Okay, this is the reason. Now, if I'm to convert 4 in base 10 to base 4, let's see what I'll get. Okay, let's see what I'll get. So look at this. So what is 4 divided by 4? It is 1. Alright, remainder 0. What is 1 divided by 4? It is 0, remainder 1. So the answer is what? It is 10. Right. Now assuming it was 5, right? Assuming it was 5. Right, so assuming it was 5, right? So what is 5 divided by 5? It is 1, remainder 0. Right, so 1 divided by 5 is 0, remainder 1. Or when you get here, because 1 is less than this 5, you can stop it and read it from this last quotient and then you come to the right. So 1 0. Right, so whenever you add and then the total gives you the same as the base, the answer in that new base is what? Is 10. Now if the total exceeds the given base, you would interpret it as 10 plus the excess of the total over that base. Right, so for example, if the total is 7, in base 5 the 7 will be what? 10 plus the excess. So 10 plus 7 minus 5, which is 12 base 5. Okay, if you want to verify whether it is true, or if you want to be on the safer side, just convert it to what? To the required base. So assuming the total was 7, and you have to convert the 7 to base 5. So 5 will be here, 7 will be here, and the remainder will be here. So what is 7 divided by 5? It is 1. Remainder 2. So you see it is 12. But then actually it was 10 plus the excess of 7 over 5. Alright, so this is just a simple shortcut I'm giving you so that it will help you in your objectives, right? Yeah. In math you need to be smart, okay, especially with the objectives you need to be smart. So that is that. So since we are adding in base 4, every number or every total we are getting, it has to be converted to base 4. So that is a basic approach, right? So we have to solve 1 2 3 base 4 plus 1 2 base 4, right? So what is 3 plus 2? What is 3 plus 2? 3 plus 2 is basically what? 3 plus 2 is 5, right? 3 plus 2 is 5. But then because we are performing the operation in base 4, we have to convert the 5 to base 4, right? So a shortcut you can use is that 5 is 11 in base 4, because we said if the total is more than the given base, you would interpret it as 10 plus the excess of the total over the base, right? So because it is more than, it's going to be 10 plus, what is the excess of 5 over 4? It is 1, right? So 5 is 1 more than 4, right? So what is 1 plus 10? It is 11, right? Okay, let's see how it is 11, right? So let's see. So as you are seeing here, so if you have to convert 5 to base 4, we have 5 here, okay, we have the 4 here, we have the remainder here. So what is 5 divided by 4? It is 1, remainder 1, right? Oh, sorry, it's supposed to be, this is supposed to be 4, okay, yeah. So it is going to be what? 1 remainder 1. I believe you get me. Yeah. So it is 11, right? Okay, so let's come here. Let's do the calculation here. So 3 plus 2 is what? It's 5, right? But then 5 in base 4 is 11, as we've done here. So we just write the last digit, right? Which is 1, and then we carry the 1 to the number at the left side, just as you do with your normal addition, right? So carry 1, alright. So now we have 1 plus 2 plus what? Plus 1, and that gives us 4. But what is 4 in base 4? It is 10, right? We said if the total is the same as the base, the result is 10, as you are seeing here clearly. So in 10, we are not going to write the full 10 here, right? So we are going to write the last digit, which is 0, and then carry 1 here. So now what is 1 plus 1? It is 2, right? So our answer is 201 base 4. 201 base 4, as you are seeing over here. So 123 base 4 plus 12 base 4 is equal to 201 base 4. Now note that you can also decide to convert the numbers to base 10, and then you perform the operation in base 10. Afterwards, you convert the final result to the original base, right? So this is what it means. So we are to add 123 base 4 to 12 base 4, right? Apart from you solving it directly, right, and then converting whatever result you get to base 4, you can likewise decide to convert each of the numbers to base 10. Right, and then you do the addition in base 10. Afterwards, you are going to convert the total to base 4. You get the same answer, right? So let's look at how we did that. So we are converting 123 base 4 to base 10, right? So when you convert it, you are going to get 27 base 10, right? So you just apply the same principles. So you get 27 base 10. So that is for the 123 base 4. When you convert the 12 base 4, you are going to get 6 base 10. So now what is 27 plus 6 in base 10 still? So 27 plus 6 in base 10 is what? It's 33. So because the numbers were in base 4, we have to convert the 33 to what? To base 4, right? And that will give us our answer straight away, right? So what is 33 base 10 in base 4? So you write a 4 here, 33 here, and then the remainder here. So 33 divided by 4 is 8, right? 4 8 is 32, remainder 1. 4 into 8 is what? Is 2, remainder 0. And then 4 into 2 is 0, remainder 2. So the answer is 201. Right, so you see it is the same as what we had here, right? So you can do it in two ways. Either you solve it directly, or you convert the individual numbers to base 10, and then you perform the addition in base 10. Afterwards, you convert the total in base 10 to what? To base 4. I believe you get it. Yeah. So let's now look at subtraction, right? So now take note of this one. I believe you know that under subtraction we always borrow, right? Yeah. So in mathematics too, we do borrow. So borrowing is not only an activity of man. I mean math also borrows, or in math we borrow, right? So anyway, I believe you know that whenever you are subtracting, okay, now take note of this point. In subtraction we borrow, right? But then whenever we are borrowing from the next number, it is the same number of the base that we are borrowing. So if the subtraction is done in base 8, whenever you borrow 1 from the next number on your left, it is 8 that you are borrowing, right? Okay, let me give you this illustration. Now let's cast our minds back to normal subtraction. Okay, normal subtraction. So assuming we have to subtract this, 425 minus 278. So this is in base 10, the usual subtraction that we've been doing all this while. Right now, usually see, sometimes you think that whenever you are borrowing 1, you are adding 1 to the number on your right. Really, you are not adding 1, you are adding 10, because under subtraction, whenever you are borrowing whenever you borrow 1 from the number on your left, in adding it to the number on your right, it is based on the particular number base that you are dealing in. So under base 10, whenever we borrow, we are adding 10, or we are borrowing 10. Let me show you. So 425 minus 278. So 5 minus 8, you can't solve, so you have to borrow 1 from these two. And when you borrow 1 from these two, it becomes 10. So it becomes 10 plus 5, not 1 plus 5. If it were 1 plus 5, it would have been 6. But you would attest to the fact that it's not going to be 6, it's going to be 15. But then because when you place a 1 in front of the 5, it looks like 15, so you think it is 1 that you are borrowing. You didn't borrow 1, you borrowed 10, because the operation was done in base 10. I believe you get me. Yeah, so that is just a point of correction, right? So whenever you borrow in base 10, you are not borrowing 1, you are borrowing 10. Right, so though you are borrowing 1, in adding it to the number on your right, it is 10. So here it becomes 10 plus 5, which is 15. Then it will be 15 minus 8, which is 7. So here we have 1 minus 7. We can't solve, so we have to borrow 1. No, we have to borrow from the number on the left. When you borrow 1 from the 4, it becomes 10. So you are going to add 10 to this 1, making it 11. So 11 minus 7 becomes what? It becomes 4. Right? And then you have 3 minus 2, which is 1. So this subtraction is done in base 10. It is done in base 10. Right? So I just wanted to show you that under subtraction, whenever you borrow the exact quantity as that particular base. So if we are dealing in base 8, whenever we borrow 1 from the number on the left, in adding it to the number on our right, it becomes 8. Right? So let us look at how we can solve this question. So we have to find the difference between 317 base 8 and 265 base 8. Difference means subtract, right? So it's the same as 317 base 8 minus 265 base 8. Right? So let's do the subtraction here. Now what is 7 minus 5? 7 minus 5 is 2, so here there is no borrowing, so just write out 2 here. What is 1 minus 6? We can't, right? So we have to borrow. Now whenever we borrow 1 from the number on our left here, because the operation is in base 8, we are supposed to add 8 to the number here. So though we are borrowing 1 from this 3, in adding to the number on our right, is going to be 8 plus the number, because we are working in base 8, right? So what is 8 plus 1? It is 9. And what is 9 minus 6? It is 3, right? So 2 minus 2 is what? Is 0. So we don't write anything there. So 317 base 8 minus 265 base 8 is equal to 32 base 8, right? Here too, you can decide to convert the 317 base 8 and then the 265 base 8 to base 10, and then you subtract them in base 10. Afterwards, you convert the difference to what? To base 8, and you still arrive at 32 base 8, right? So you can try that one on your own, right? So that is the basic principle that is used under subtraction of numbers in non-decimal basis. Okay, let's proceed. What about multiplication? Right, so for multiplication too, you are going to arrange it the same way, the same vertical order that you arrange numbers when you are multiplying. So here we have to find the product of 23 base 5 and 4 base 5. So we are performing the multiplication in base 5, right? So we are going to present it this way, right? We are going to present it this way. Then we are going to multiply, but then whatever product we get must be converted to that particular base, which is in base 5. Right, so let's do the solving here. Right, so what is 4 times 3? 4 times 3 is 12. But what is 12 in base 5? So we did a conversion here, right? So 5 goes into 12 2 times, right? Remember 2. Right, so our answer becomes 22 in base 5. So because it's 22, we just write the last number, which is 2 carry 2. Right? Good. Now we multiply the 4 here by 5. Sorry, by this 2 here. So what is 4 times 2? 4 times 2 is 8. And then we add it to the additional number that we had here, right? So what is 8 plus 2? It is what? Sorry. Yeah, what is 8 plus 2? 8 plus 2 is 10. But we have to convert the 10 to base 5. So in converting, we had 20. So 5 into 10 is 2, remaining 0. So our final answer becomes 202 base 5. Right, so that is what you are seeing here, 202 base 5. Alright. So with this one too, you can also convert 23 base 5 to base 10, convert 4 base 5 to base 10, and then you would multiply them in base 10. Afterwards, you convert the final result to base 5. So the choice is yours. Either you multiply them directly, or you first convert them to base 10, perform the multiplication in base 10, and then you finally convert the result to the original base, or to the base given, which is base 5. Right, so I will leave you with this particular one, 321 base 6 times 25 base 6. So you can pause the video and then copy the question. Right, you may decide to copy the answer or not. Right, so you try it on your own, and then you come back and then come and check whether your answer is correct. Right, so that is that for multiplication of numbers in non-decimal basis. So now let's look at the final operation, which is the division of numbers in non-decimal basis. So here we are going to apply the long division method, right? The long division method. So let's look at this question. Given that P is equal to 242 base 5 and Q is equal to 14 base 5, find P divided by Q. Find P divided by Q. So it means what is 242 base 5 divided by 14 base 5? So here we can use two different methods. Either we use the long division method, or we use the we convert the individual numbers to base 10, divide in base 10, then we convert back to what? To base 5. So let's look at the long division method here. So obviously the dividend, or the first number, will be in the box, right? And then the second number comes outside, right? So we have 14, and then inside is 242. Bear in mind everything is in base 5, right? So in dividing 2, we have to take note of that, right? So how many times will, let's pick the first two digits, right? How many times will 14 divide 24? Right? How many times will 14 divide 24? Okay, it is 1, right? 14 times 1 is 14, and then we subtract, right? So 4 minus 4 is 0, 2 minus 1 is 1. Then we attach this. We have 14 dividing 102. Bear in mind everything is in what? It is in base 5. Everything is done in base 5. So what is the result of 102 divided by 14? Right, so the answer is 3, right? The answer is 3, right? So let's look at why it is 3, right? So 14 times 3 base 5 will give you 102, right, in base 5, right? So 4 3 is 12, and 12 in base 5 is 22. So 2 remainder 2 carry 2, right? 2 carry 2, and then 3 times 1 is what? Is 3, plus 2 is 5. 5 in base 5 is what? Is 10. So the answer is 102, right? So it means that the result is what? Is 3, right? So 14 times 3 is 102, right? So it means our final answer is 13, right? 13 base 5. Now, I don't really recommend using this method, okay? So it's always better you rather convert each of the digits or each of the numbers to base 10, and then you perform the division in base 10. Afterwards, you convert the results to base 5. Alright, so that is the second method here. So what is 242 base 5 in base 10? So when you solve it, you are going to get 72 base 10. 14 base 5 in base 10. When you solve, you are going to get 9 in base 10. So now what is 72 divided by 9? The answer is 8. Then you convert your 8 to what? To your base 5. So in converting 8 to base 5, so 5 goes into 8 one time, remember 3, right? So that is our final answer, 13 base 5, right? You see we are getting the same answer, so 13 base 5, 13 base 5, right? So whichever method you like to go with, the choice is yours, right? But I recommend using the second method, right? Because that one is straightforward, it's clearer, right? Okay, so let's now look at equations involving number bases. Right, so we have a question here. We have to find the number base n such that 365 base 7 plus 43 base n is equal to 217 base 10. Right, so how do we go about this question? Well, we are going to basically convert everything to base 10. Bear in mind, this 217 is already in base 10, right? So we need a common base, a standard base. We need a standard base to work with all these numbers, right? So this is in base 7, this is in base n, right? This is in base 10, right? So let us try to convert everything to base 10, right? So in converting 365.7 to base 10, it is the same principle you are going to use, right? So 3 times 7 plus 6 times 7 plus 5 times 7. Then we raise them to power. So starting from 0. So 0, 1, and then 2. I believe you get it. Yeah. So that is for the 365 base 7. For the 43 base n is the same thing. So here the base is n. So it's going to be 4 times n in one bracket plus 3 times n in another bracket. And then we are going to raise the n to 0, to the power of 0 here, and here to the power of 1. Now this one is already in base 10, so there is no need for us to convert it again, right? So it is the same as 217. Then we solve, okay? So it's going to be 3 times 49, 6 times 7, and then 5 times 1. This here is going to give us 4 times n plus 3 times 1. So n to the power 0 is still 1. So anything at all to the power 0 is 1. Whether it's a letter or a number, it is still 1. Right? So everything is equal to 217. Then we are going to multiply and then add, right? So what is 3 by 49? 3 by 49 is 147. 6 by 7 is 42. 5 times 1 is 5. 4 times n is 4n. 3 times 1 is what? Is 3. And everything is equal to 217. Right, so we are going to add everything here. So 147 plus 42 plus 5 gives us 194. And then we add the 4n plus 3 is equal to 217. So from here we can simply group like terms, right? So we have 4n plus 194 plus 3 will give us 197. And everything is equal to 217, right? So 4n is equal to 217 minus 197, and 4n is equal to 20, right? So when you divide both sides by 4, your n will give us 5, right? So it means that the base here is base 5. The base here is base 5. So you can try it. You may decide to test your answer and see whether you are right. So you convert 365 base 7 to base 10, and then you convert 43 base 5 to base 10. When you add the two, you are going to get 217 base 10, right? So you can do that one on your own, right? Okay, let's look at this final example. What is p if 3 times 14 base p is equal to 45 base p? Right, so this is a simple question. So 3 times 14 base p is equal to 45 base p. So here let's try to convert everything to base 10, right? So in doing that, I'm going to have 3 into bracket 1 times p, because the base is p, right? 1 times p plus 4 times p. But the first p here will take the power of 0, the second p here takes the power of 1, right? And then at the right side of the equation too, we have 4 times p plus 5 times p. But the first p here will take a power of 0, the second p takes a power of 1, right? Then we just solve the bracket. So we are going to have 3 into brackets p plus 4, because 1 times p to the power 1 is p, and 4 times p to the power 0, that is 4 times 1, it is still 4. So that is for the left side, right? To the right side, 4 times p to the power 1 is still 4p. 5 times p to the power 0, so 5 times 1 is 5, right? So from here we just expand the bracket. So we are going to have 3p plus 12 is equal to 4p plus 5. So when we get there, we just group like terms, right? So we are going to bring the 5 to the left side to come and subtract, and then we take the 3p to the right side to also go and subtract. So in the end we are getting 12 minus 5 is equal to 4p minus 3p, right? So 12 minus 5 is 7, 4p minus 3p is p. Therefore our p is equal to 7, right? So that is basically how to solve equations involving number bases. I believe it's clear, right? Okay, so this is where we bring the lesson to an end. I believe it was well explained, it was simple, and it was clear, right? Okay, so thank you once again for your audience, and until I see you in the next lesson, bye bye, stay blessed.